think so. So we might as well dive in with 46 over here. So election winners. Let's see what it's asking. Elections are in progress. So we're given an array of the number of votes given to each of the candidates. So like something like this, for example. So the first candidate or the 0th candidate would have 2 votes. The candidate 1 would have 3 votes. Candidate 2, 5 votes, etc. And we're also given this k value, which represents the number of votes that haven't yet been cast. And we want to find the number of candidates who, still have a shot at winning, basically. Like if they got all the votes, could they win it? That's basically it. And we can't have a tie. We have to have strictly more votes. They have to be, strictly the maximum. Okay. So on its face, the problem is pretty simple, but it actually, this one has received a surprising amount of, a lot of people don't like it, I guess is what I'm trying to say. And I think the reason is because we're going to find that it's kind of hard to avoid making our code look a little bit sloppy in this case. Anyway, you'll see what I mean. We'll get into it now. So we might as well just start with something like this. Let's say, first of all, if we want to know who can win this, basically what we're looking at is we're kind of trying to compare this to the maximum. Whoever's in the lead currently, if some other candidate got all the votes, could they beat whoever's in the lead right now? That's basically the idea. So let's say let max be assigned the value of math.max of votes. And okay, right off the bat, there are going to be 2 issues with this. We'll see if it's working. And well, no, it's not. And the reason is, we're probably getting used to this by now, but we need a spread operator here because we can't find the max of just one element, especially if that element is an array. It doesn't make a lot of sense. So max, we have to use the spread operator so that it's looking at the maximum of all of these as opposed to the maximum of just this one array. Okay, so 5, that looks good. It is the max. 3 is the max over there. Okay, cool. So then the other issue I have with this is max, well, it's not really going to change. We're not going to reassign the value or anything like that. So we might as well just make that a constant. Might as well. All right, cool. So we've got the maximum now. And then we might think okay, let's say, because we're looking for basically how many potential winners there are, right? So let's say let potential winners be assigned the value of 0, first of all, right off the bat. And ultimately, this is the thing that we're going to be returning at the end of this. We want to know how many potential winners are there. And I guess I could have called that variable a number of potential winners, but I don't want it to be too long. I think some people would already say it's pretty absurdly long. Anyway, okay, you know what? There is actually something that's bothering me about this. Calling this votes, I find a little misleading. I'm going to call this candidates, and then the inside, what we actually have inside this will be votes. Because basically what I'm trying to say is saying votes for the name of the array feels like it's kind of insufficient because each candidate gets a plural number of votes. Normally if it was I might do let vote of votes or something like that, but it's not just one vote, it's their number of votes. So basically each of these represents a candidate. The number inside represents the number of votes that candidate got. So I don't know, that's a personal preference thing. It's up to you. But what I'm saying is for let votes of candidates, if votes plus k is greater than max, and notice it's got to be strictly greater than max. In that case, potential winners plus is right next to the backspace. So sorry about that. Anyway, let's run that. Let's see if that works. And no, well, okay, it passed 5 out of 6. So it's doing a pretty good job for almost all of these, but there's just one that's kind of posing a problem here. So test 3. Well, what's the issue here? It's this. And someone did point this out in the comments that it seems a bit ironic that we're saying elections are in progress, yet we're also saying there are no votes that have yet to be cast. But I guess the vote counting is part of the process as well. So anyway, so there is this possibility that maybe there are no votes to be cast whatsoever. So okay, we can probably deal with that. In fact, we could just say, well, if there are no votes, if k is 0, then return 1, right? Because it's just going to be like just the one winner. If there are no votes to be cast, well, yeah, the winner's already got it. It's in the bag for them, right? So let's run that, and that should give us the answer we're looking for. I'll just delete that. Oh, okay. So now it's actually doing worse than before. Let's take a look at why that is. So, okay, this is another case where k is 0, but the expected output is 0 here, not 1. So let's investigate why that is. Basically, the reason we were saying return 1 is because we were trying to say, well, if there are no votes left to be cast, then obviously whoever's in the lead will just be the winner. But we didn't consider the case where there's a tie for the lead right now. So if there's a tie, we're going to say, yeah, no potential winners. So we've got to consider that case. And now I'm wondering about this other one that failed. Okay, so this is funny because we have 6 sample tests here, 6 visible tests. And half of those have a k value of 0. That's, it's kind of weird. Anyway, point is, so in this case, now they're all tied. We definitely don't want to be returning 1. There's not going to be a winner in this case. So I'm starting to think we're basically just going to have to do 2 totally different things depending on if k is 0 or not. So let's start it out that way. We'll say if k is 0 and else we'll do something else. And specifically, what else are we going to do? This. So we'll get that in there. We'll indent that real nice. Clear up the space. Okay, so if k is 0. Well, what do we want to do if k is 0? Then basically we want to say, is there a tie? And if there is, return 0. If there isn't a tie, return 1. That's, yeah, that's pretty much it. So how are we going to do that? Well, we basically want to find the maximum, and we want to find like how many times the maximum is occurring there. So how could we do that? Well, I guess we could do something like this. The max, maybe that's something we'll use in both of these cases. So we'll just put that out front, clean that up. And okay, so if k is 0, then basically what we want to say is, if there's more than one instance of the maximum here, then return 0. Otherwise, return 1. So we'll say something like, well, there are a few ways we could do this. Actually, we were sort of looking at something like this last time. There was one where we were sort of like counting the instances of a character in a string. So we could do the same sort of thing for that. Since we're talking about an array here instead of a string, though, I think we might as well just use like a filter or something like that. So we could say if candidates.filter, and then we'll say votes equals, let's go with a triple equal max, and same thing up here actually. Okay, yeah, so basically the idea is that we're filtering this down. We're taking the entire array of our candidates' votes, and we're saying, well, let's filter that to the ones that just have the number of votes equal to the maximum. So in this case, it would just return an array containing 5. In this case, it would return an array containing both these 3s. In this case, yeah, just the 5 again. In this case, it would return the whole thing because they're all equal to the maximums. Okay, so that's basically what we're looking for. But really what we're looking for is how many are there, right? We don't need the actual array with all of these things in it, just like we don't need the actual array with the 2 3s. We just need to know how many of the 3s are there. So in other words, we're looking for the length of this thing. Okay, so if this length is greater than 1, okay, well then we're going to have to do some stuff. So, well, actually, pretty much, if it's greater than 1, return 0. And if it's not greater than 1, return 1. I mean, that's pretty much it, right? So let's run that. Let's see if that works. Oh, okay, yeah. I meant to hit the equal sign there. Oops. Okay, cool. So that's passing all the visible tests. Let's try submitting it. We'll see if it passes the hidden test. And it does. Okay, so that's good. Nice stuff. Let's get that out of the way. Oh, that's weird, eh? No data to display. Page 330 maybe? Oh, there we are. Okay, so I wonder how that happened. Anyway, okay, going back to this, we're passing all the tests, which is nice, but I want to try to clean this up a little bit because, I don't know, it's, like I was saying, it is hard to avoid making this problem look kind of sloppy, but first thing I want to point out is we used a filter up here, right? Just to see like how many candidates were tied in first place for the event where there are no votes left to be cast. So we could do a similar kind of thing over here. So potential winners, if you think about it, potential winners is basically just this. Okay, we could say something like this. Let potential winners be assigned the value of candidates dot filter. Do another filter for this one, and we'll say votes. It's mapped to basically if votes plus k is greater than max. That's pretty much it, right? I mean, those are our potential winners. But again, we're looking for how many of them are there. So we'll do a dot length on the end of that. There we go. So that's our potential winners. And that means we wouldn't have to do this loop here or anything like that. And in fact, we wouldn't really need to give this a name or anything. We just get rid of all that and say, just return that. Or at least hopefully that's gonna work. Yeah, there we go. So that's a little nicer, maybe, depending on your perspective here. If you like using filters, if you like sort of, functional programming kind of stuff, then yeah, this is maybe a good one. Now, okay, the next thing I want to address is this stuff up here. We've got this thing over here, which is basically saying, well, if this thing is greater than 1, then return 0. Otherwise, return 1. Okay. And actually, before we take a look at this, there's actually another maybe larger thing I want to take a look at, and it's this, because we're basically saying if k is 0. But remember, this whole typecasting business, if we were to just say if k, then basically if it is 0, it'll typecast that to false, and it'll say, oh, okay, no, we'll go down to the else. If it's not 0, it'll go to this one. But that's kind of the opposite of what we want, so let's cut that out. We'll take this one, we'll put it up there, and we'll paste that back in. Now let's run that. And okay, great. So depending on your perspective, this might be better or worse. I mean, the main thing is that having the equal 0 in there is kind of a nice thing for the purpose of clarity, but it's a little tighter if we do it this way. The main reason I wanted to do it this way is because I just wanted to illustrate this point. I just wanted to remind everyone about this idea of typecasting, the idea that this number is going to get typecast into a boolean. Okay, now the reason I wanted to mention that is because it kind of works the other way as well. So let me show you what I mean by that. Okay, so first of all, let's do this. If, let's just say the number 1. If 1, then return true. Else, return false. Okay, and so we're sending this up just to sort of see like how these numbers are getting typecast. So we'll run that. 1 is going to get typecast to true, so there we go. And in fact, any non-zero number is going to get typecast to true, even if it's a negative or something that's not, anything that's not 0, basically. If it is 0, it's going to get typecast to false. And there are other things like that, like I think empty string is going to get typecast to false and stuff like that. So, lots of ways we could use this. But the main thing that I wanted to do is to try to do the reverse. So basically, return something like, well, let's try this first of all, parseInt of true. We'll see if that works. And no, it doesn't. It's like, what are you talking about? That's a true. That's not an integer. We can't get an integer value out of that. Okay, well, you know, it was worth a try. But here's something really interesting. If we actually multiply this by 1, so we've got a Boolean value, we're multiplying it by the number 1. And what does that do to it? Turns it into a 1. Okay, cool. Well, let's see what it would do if we had a false. So false times 1. What's it going to do with that? It's going to turn it into a 0. Well, that's pretty interesting. And the reason I'm mentioning that is because, you know, sometimes we've seen situations like, you know, if Boolean, you know, whatever we want it to be. Oh, I got switched to French keyboard. All right. Oh. There we go. So if Boolean, then return true, else return false. I see a lot of people kind of falling into this trap. And the thing is, anytime you've got a situation like this where you're using an if statement and the only contents of your if else statement is basically either return true or return false, we're doing more work than we have to, because this, all of these lines here is exactly equivalent to just saying return Boolean, in the sense that, you know, like we could say like, I don't know, something like 5 equals 6, right? And we should probably get a false out of that, right? But we could also just say something like this, return 5 equals 6, and that would also return false. Okay, so that's the sort of thing we typically want to avoid, you know, where we use like 5 lines instead of 1. And like this is just totally redundant. I don't think this is increasing the clarity even. So we have a similar, not entirely the same, but a similar kind of situation happening over here. Because basically we're just saying if this Boolean, then return 0. Otherwise, return 1. Okay, so could we do something like, you know, just return that Boolean? Is that going to work? Or actually, let's switch it around. So that's less than or equal to 1. Basically, it's just equivalent to switching these. So actually, here, let's make sure this is all as clear as possible. So there. First of all, I'll just comment this out to see if it's still working. It's still working. Great. So could we do something like this? Would that work as well? Would that be fine? Let's find out. No, because here we're giving the answer of false, but really what they want is an answer of 0. So here's what we're going to do. We'll take this whole Boolean and we'll do what we were doing above. Multiply it by 1. And that's going to typecast our Booleans into numbers, 1 or 0 specifically. So I guess I would say I feel a little bit better about this. I would say this is looking a little nicer. I mean, there are other ways we could do it. We could even, like, if we don't want to have 2 return statements like this, we could just say, we could do like a ternary, you know, like return k question mark. I might as well do that. So return k, and if k, then this. If not k, then this. So that's another way of saying the same thing. We don't have to have 2 return statements that way. But is it nicer? I don't know. That's hard to say. I feel like it's a bit of a run-on sentence. You know, it's kind of like anytime it wraps onto the next line like that, I feel a little uncomfortable about it. But then again, I do like ternary operators. I think they're pretty cool. I like the fact that we're just returning one thing. I guess, let's see, is it going to pass the hidden tests? Yeah, it passes the hidden test. So, okay, I guess we'll leave it at that. I mean, you can sort of see, I hope, what I was trying to say earlier, which is that, like, just because of the fact that we have to worry about k, and then on top of that we have to, and sorry, what I mean is we have to consider whether or not k is 0. And then on top of that we have to consider whether or not there's a tie for the lead. It just kind of complicates things, and it means that, you know, we've got like a lot of kind of, I was about to say exceptions, but that kind of means something different in programming. We have a lot of different scenarios to consider here, and so that's why it started out with like a lot of ifs, you know, lots of ifs, elses, and stuff like that. So we've been able to compact that quite a bit. Is it better? That's hard to say. Here's what I'm going to do. I'm going to copy this, and I'm going to do like a billion undos until we get to the point where we actually have like all of those nested if-else statements and stuff like that. Oh no! Okay, so we can't go any further than that, I guess. Was this basically? Yeah, I guess. I don't know. You know what? I don't think we can recover it. I guess we'll just have to, you know, hit rewind on the video if we want to see that stuff. But anyway, we'll leave it at this for now. I think I submitted that already, so might as well just move on. So that was election winners. Let me know if you have any questions, comments, or concerns, suggestions, ideas. Hey, whatever you got, feel free to leave a comment. Okay, so